to physics and mathematics lovers. Before us here is a question on mapping function. The question says, determine the domain D of the mapping f as f mapped on this function into what? 2x minus 3. If C equal to this set of numbers is the range and f is defined on D. Alright, so this is a very simple question. Solution. Now we are given a function. This is a function here. Remember, a mapping is a relation, a quantitative relation that exists between two quantities. That's function. Yes, exactly. So function is a quantitative representation or quantitative relation that exists between two quantities. If you look at it now, in mapping, we have the domain. The domain, let's say for example, if I have as f map, let's say x is a map into y, and this is a function that is defined on it. So for example, I am having an element here. Let's say I have x1, x2, x3, then x4. So this is one here is the domain. Then I'm having here y1, and y1 here is an element of this set. So we have what? Y2, y3, y4. Now, this can only be called mapping if there is a unique image. When I decide to map x1 to xy, so y here is an image of this what subset in x. These are subsets in this what defined what sets. This one here is called codomain. Yx here is a domain. This is a domain D. Then y this one is a codomain. Codomain. Alright, in the short form. So this is called the codomain, and this is what the domain. Now, mapping can only exist if every element in the domain has a corresponding image. I will call it what? A unique image. It means that if I map x1 to this now, so y2, I map it to y2. So y2 is an image of what? X1. So conversely, x2 now is called the pre-image. Pre-image of what? Y2. The same way, if I map x3 to this y3, then y3 is the image of this. Why this one is the pre-image of this element here. So the same way, this is how mapping exists. This is an arrow diagram representation of what? Mapping in a function. So if you look at this question now that is given to us, there's another thing that you need to understand in mapping. In mapping, the subset of the codomain, the subset of the codomain, which are the images of the domain, is called range. So it means that what? My y1 here, if I want to write range, R, my y1 here, y1, then y2, y3, y4, this is the range of this what? Mapping. So in this case, we are going to use this relation now to answer this question, which is very what? Easy. Now it means that what? In this x, if this is a function defined on x mapped to y, it means that what? For me to get so let's go. So let's do this way. Now, it means that what? This element here in a set notation, if I'm going to have it means that your x is an element of x. So y, we also have it here, this is small letter y, is also an element of what? Y, which is this set. So they are what? The elements. So for us to get this our y, to get the image of this, so it's going to give us well, your small y equal to a function of x. So this is how it is what? written in our mapping. So now for mapping to exist in this case, it then means that what? Every element of the domain must have what? A unique what? Image. It must have what? Corresponding what? Image. So therefore, we are now giving this as the range now. Meaning that what? This range that is here is the images of this what? Elements. Okay. So mean that what? If our range now, our range R, okay, they gave us a C there, C equal to, we have -3, we have a -1, we have a 5. If we say that what? This range here is the image of this domain. How do we get the domain? Since in this case the domain is not given to us, but we are giving a function defined on this. So defined on this mapping, which means we have f defined on S, set of real numbers, mapped into what? 2x minus what? 3. So this is our function of x now. What this means is that this is a function of what? X. So you can as well say that what? F of x now is equal to 2x minus what? 3. This is our f of x. And remember, when I define the range, I told you that the range, how do we get the range? Which is the image. Each image of the domain is obtained by what? Saying your y, small letter y, equal to a function of what? X. Okay. So in this way now, we are going to use this now to solve and get our what? The domain. So in this case, let's go. What we are going to do now, for us to get the first element of the domain, we're going to say your what? This is your y1, your y1 equal to what? Function of what? x1. All right. How do we get this one? Remember, the first element here, x1 here represents the first element in the domain. While this your y1 here represents the first element, which is a subset of the codomain, now known as the what? The range. So what we are going to do now, we are going to plug in this into this for x. Since we said that what? The y now as your element of the codomain, which happens to be our range here. So we are going to equate it to this our function of what? X. You do it respectively to get every what? Elements in the what? Domain. So which means that the first element in our range, which is the image, is -3. Then equal to, then bring here the function f of x. Now we are now taking f of x in general. This is it now. So what is the value? Give it to us. 2x minus 3. So we have 2x minus 3. So at this end now, we are going to look for x. Find the value of x. So this implies that what? Then you take this -3 to this other side. Then we have a -3 plus, because this -3 crosses to this side, it becomes what? Positive. Plus 3 equal to 2x. And at the end of the day, we are going to have a 2x equal to 0. And this implies that what? X equal to what? 0 over what? 3, which is what? 0. It means our first element in the domain is what? 0. That is what? x1 equal to what? 0. Okay. Now, let us get for x2. So for us to get the x2, the second element, we are going to use this to equate equal to the function of what? X. So, which means we are going to have -1 equal to 2x minus 3. So this also implies that you move this one to this other side, it becomes what? -1 plus 3 equal to what? 2x. So now, -1 plus 3 is going to give you a +2. So which means we have a 2x equal to what? 2. Now cancel both sides by what? 2. Divide both sides by 2. Divide both sides by 2. So this is gone, this is gone, we have 1. So it means that what the second element is what? X2 now is equal to what? 1. Okay. So let's solve for the next one. So what you do now, the last element you are going to get now is plug in this one in place of y. So that will give us a y3. Okay, so the next thing you do now is to use that to substitute. So let's go, let's clean here. Now, let me finish it here. What you do is the third element, which is from the domain, for us to get it, now we're going to have a 5 equal to then 2x minus 3. Then move it. Then minus 3 cross to this side. Become 5 plus 3 equal to 2x. Then we have 8 equal to 2x. So divide both sides by 2. 2 here, 2 here. Then this cancels this, one cancels this. And then here is 4. So which means the third element of the domain is 4. So your x3 equal to what? 4. So in this case, you are going to replace every one of them, put them in the domain. This is your, we assume this one as our range, which is y1, y2, y3. But in this case now, our domain, we are going to put it this way to the answer, having evaluated them. So you know that your x1, your domain now, will now give us equal to your x1, x2, and x3. Then what are the values? The first one, we have 0. Then the second one, we have 1. The last one, we have 4. So this is the domain, the elements of the domain to this question. If you find this class very interesting, please do not hesitate to share this video. Also subscribe to our YouTube channel, Physics and Mathematics Lover. Thank you. Bye.